So this is a small correction. It's not C++, it's C#. You all know that, right? Okay. So we're going to look at programming variables in C#. So what is variable? What is variable? What is a variable? Anything that I can wear is a variable. My shoes are variable, right? Well, then we are talking about programming variables. So what are the variables that you know? Come on, tell me. Watch, okay. Is your watch is your watch programmable? No? Okay. Okay, Fitbit. So now you tell me. Can you see it on the screen? What are those? Do you see Apple Watch? Yes. So we're going to program for Apple Watch using WatchKit. WatchKit is the iOS SDK for building Apple Watches. Okay? We're going to look at Android Wear. Now, in Android, there's a concept called Wearables, where the two things included. One is Android Wear, which is generally known as your watch. And there is also the Google Glass. Have you heard of this? It was known as the Project Glass when it was launched. Has anyone tried it? Great. Does anybody have it here? Okay, I'm lucky. Otherwise, you are lucky because we could have shown you how to program that. And last but not the least, latest to the party, Microsoft Band. What do you feel looking at this slide? There were days of Casios, Citizens, Armanis, Rados. Today, watches are manufactured by Apple's, Google's, Microsoft. We're entering into that era, right? Now, what is good about this is we're going to look at programming all of this in C#. How many of you are C# developers here? Okay. How many of you are not C# developers here? I know you. You're a game developer. Who else? Nobody else? Everybody is a C# developer. So the whole idea of this talk is to give you a primer on variables and to prove it to you that you have the skills to write your future, because we are entering into the next decade, which is going to be the wearable decade. One important question that you need to ask before you start is, why should I program for wearables? Can anybody tell why should I program for wearables? Make life simple, okay. How is life being simple? You have WhatsApp on your phone. Does it make you simple? How many notifications do you get in between the conference? How many of you get messages? I know there is absolutely no network here, so you're all lucky, right? But otherwise, it's so damn crazy. Right, so this is one important question you need to ask yourself: why programming for wearables? And we will answer this. I want to put forward a quote. I know this is against every presentation principles to put a huge quote there, but I found it really interesting from Ben Hammersley, who writes for Wired, and I just want to read it out with you. Wearables are truly upon us. It takes about a decade to shift from the basements of the 70s to the desks of the 80s, the laps of the 90s, and pockets of 20 teens. The location of hot computing, the place where the most interesting developments are happening, always moves and shrinks with every generation. And the last line, so very important, is although this decade is all about smartphone, today we are starting to see the path to the next stop, which is the constant progression, if not in, then definitely on the body. We are entering into the world of sensors. Your body is going to be fitted with so many sensors possible, collecting all the possible information that can scare your hell out of your life. That is true, right? Look at the wearables that I'm wearing. I have a Moto 360 on my left. I have a Fitbit on my right. I'm very concerned about my health. No, I'm not. But these gadgets definitely make me, right? But we're not here to talk about that. We are here because we are developers. We are getting into a world of wearables, and it's time to prove that we can program the future. The first wearable was coined, I think it was, I don't know if we can call it invented, but it was first formed in 1961. It was majorly for gambling. purpose. So let's not go there. There's something that you remember in your last few years. Do you remember this? This was the coolest gadget when I grew up. I don't know how old you are, but when I grew up, definitely this was the coolest gadget, because in the school, if somebody else is wearing this thing, it doesn't matter, right? You just want to key in and see. You don't want to count 2 plus 2, but you definitely want to see how that happens. Now, that was a gadget that we all knew. Now, what has changed today? This? That's an Apple Watch with a calculator app. That's a joke. Don't quote me anywhere this. This is not where you're getting into wearable, right? Of course, this is not that. It is definitely more than that. You know, I speak to my watch more than I speak to my wife. Obviously, you know the predictable answers that the watch can give you, right? So somebody asked me, I mean, he was a developer, and I happened to talk to him about voice APIs, and he just asked me, you know, does it take for Indian audience? So he just asked me in this Indian tone. I said, it's getting better. If you want to see it happen, just come to the booth, I'll show you. When I speak, all that I need to do is I need to open this, and the watch face shows up, and I just have to tell, OK, Google, and there you go. It's trying to recognize, right? It's trying to recognize whatever I'm speaking. So it says, do little more stuff. It can show you notifications. Now, I was in Xamarin Evolve, one of the biggest mobility conferences that happens. This last time it happened in Atlanta, and I was talking to this gentleman, very important guy. I was talking very, very seriously to him. And within 30 seconds, 1 minute, what he did was, right? Do you get what I'm saying? He started doing this. You all have had picked up some habit in your lives. It's good that you're in a conference. Go out, see, watch the people, what they're doing. Nobody is sitting idle just like that. Within few seconds, you will see him pick out something like this and do this. Absolutely nothing on the screen, but you just want to know what notifications you got. That is the place we are. Now, that thing is changing. How is it changing? This. It is pretty annoying, actually. You know, you're speaking to someone very seriously. How does it look? It looks as if, oh, I'm busy. I have no time for you. Something like that, right? But that is where we are getting into. Now, notifications, if you're a developer, be considerate in notifying users. Don't notify very often, okay? You have to find and build a strategy how to notify users. Now, this is a screenshot from the Google Glass. That's how the notification looks. It's called using the Google Card Views. Your wearable is also a fitness companion, which means it has so many sensors to judge what kind of health you are carrying. It can find out what's your blood pressure now. Are you going to get a heart attack in the next 30 seconds? It can dial an ambulance for you. Yes, we are getting into the world. I'm not joking. I'm serious. Right? So when you're working day in and day out, it can tell you, OK, guys, this is 30 seconds. Get up. Now go walk. It's bad for health to sit for a long time. Who used to say that? Nobody. Today, these things are going to make our life, should I say, simpler or complicated? But that's up to you, the way you use it. But this is where we are getting into. So I was talking about the fitness companion. This is the Fitbit that I had a few months ago before I got the watch. I still have the data in it, so that I cannot literally remove this and throw it, because I have my friends. I'm actually competing with them in terms of steps that I do take every day. So yeah, tough life, right? Wearables can be a great use case for showing maps. Now, when Apple announced the Apple Watch, they also told about a vibration feedback on the watch. That means if you want to turn left, it's going to give you some kind of a vibration which you know that you have to turn left or right. I don't know how that is, because nobody has seen an Apple Watch in action, so we don't know how exactly that performs. But these are the things that we're getting into. You have maps that's going to give you feedback. You don't have to technically look into the screen. So you're driving, you know when to take a left, or you know when to take a right. Another interesting use case, obviously that doesn't come with the watch, a custom. Anybody uses Uber here? Okay, others are Ola, taxi for sure, whatever. To call a cab, you just have to say, hey, I need a cab in 10 minutes. That's it. That's where the world is going. So this is a custom app. This is an Uber app which they showcased. And a lot more which is in your hands, right? There is a nice app from Expedia. It tells you a glance of when you want to check in, when you want to have checkout, what are the other information, all those things, right? This is a screenshot of an Apple Watch, but technically whatever I'm speaking here is applicable to almost all the wearable as of today. So, being a developer, that's a nice animation, right? Did you see that? That's pretty cool. That's why I like the keynote than the PowerPoint. It gives really cool animation. So time is now. It's time for you to build for watches or wearables. Let's get started. First thing we're going to look at is Android Wear. Now, to look at Android Wear, you just have to feel and believe that it's Android for your wrist, right? Now, here are the few things that you should know, what Google says. This is all from the Google documentation. First thing is you have synced notification, which means you will have a notification on your phone, and the same notification will come on your watch. You don't have to do anything. You don't have to do wearable programming for that. You just have to use the latest SDKs, write notification compact builder.build, and then notify the user. If the watch is connected to that phone, even the watch will get the notification. You don't have to do anything else extra. But if you were working on a previous app, let's say you're not working on the latest SDKs, you may have to write an app compact library and then make yourself support for that. Another important thing to remember is the voice actions. So you just say, you just saw me doing this, okay Google, and then I can actually text my wife, I will be late or I'll be late by 5 minutes today, or something like that, right? So text my wife. Now the text is a voice action. So if I have to build my own app, like let's say Uber, book my cab. Now that book my cab will become an action. So that's how you're going to program. You don't have to write speech recognition because that's taken care. That text is converted and given to you. Your command is getting fired, and then you will have to figure out a way how you want to handle it. And also, there is wearable apps that can truly rely on your watch. Now, other thing that you have to remember is these apps have to have a handheld app as well, which means they should be a mobile app as well. You cannot just have a Wear app and ship it. It's not possible. You have to package it together. You seamlessly send the data between the watch and your phone. So how that happens is seamless. It's Bluetooth, obviously, but it is taken care by the operating system. You just have to handle a few callbacks, and that is taken care. Few things to remember. Android Wear was first introduced with the Android version 4.4W. W stands for Wear, and it is API 20 for all developers. It is also supported in Android 5.01 as well as the 5.1, which is the latest one. Remember that it has no internet connection, so you cannot technically have any code which connects to internet on your watch, but you can have code that will have a callback on your phone that can connect to an internet in the background. So I told you it requires an Android device, and it has to be packaged with the phone app. Now, how do you set up? It's very simple. Make sure you have the SDK tools and API bits installed. The one which you require is 24.0.0 or higher. And the next thing, if you don't have a watch to test, you can create an emulator. You know what's an emulator? Yes. So you create an emulator. We'll see this in action now. Create a watch emulator. So let's do the first demo. Ready? So we'll do an Android Wear. So every demo that I'm doing here can be done in Visual Studio. Everybody uses Visual Studio here? Yes, so you can do it in Visual Studio as well. So Xamarin Studio is a free IDE, and it helps me write on. Okay, so if you didn't know, these are beautiful monkeys. You can ask me questions and win these. If you want more of this, you can come to a booth and we'll tell you how to get this. So getting back, so you have the Xamarin Studio, which is a free IDE. So I'm going to start with File, New, Solution. If you were to build an iOS app or an Android app, you just go to iOS and then select the app that you want to create, let's say iPhone app or something. Now let's go to Android, and within Android I have something called as Android Wear application. You all can see it, right? You can all see it?
You can see it. So that's the Android Wear application. All I'm going to say is my first watch app. So what it's going to do is it's going to create a watch app. Before this, I show you how to create an emulator. So you go to Tools, you open the, okay, let's start with SDK Manager. So I'll open the SDK Manager, and this is where you have to go to 5.0.1 and make sure that you support Android Wear Intel x86. That should be installed. Now, if you wear an x86 machines, you have to use that because that will make your life simpler and faster. But also you can use ARM emulation if you wish to, but that's a lot slower, so don't use that. Once you have these, then the next thing that you need to do is open the Android Emulator Manager and create an emulator. So to create, you just create. This is nothing, there's no rocket science here. It's all there in the Google developer documentation. You got to do this exactly the same thing. So I select Android Wear. Now there are two options. You can select a round and a square. So round is what I'm wearing. So that's how it will look on a round. And there is a square as well. So there are square watches like the LG and the Asus and all those things. So you can choose which one you want, and then choose your API level and then set it up. So I've already set this up. So let's kickstart this. So once you create it, you can pretty much just say start, and it will open up just like an Android or any other Android emulator. So it's just that it's slightly smaller. So that's the animation that comes up. So let that start. Let me explain you how this works. Now, a few things that you need to remember. Everybody remembers NuGet package? NuGet package. So Android Wear has been shipped as part of the NuGet packages. So when you work on Visual Studio, make sure you get that package in your NuGet. So this is a template that I use. So I say file new Android Wear, it is taken care for you. But if you are writing yourself, make sure you do that. Okay? And don't worry, even Visual Studio has that. So that's about it. Now, everything starts with a main activity. And before that, let's go to the resources. If you know how Android works, the UI is designed in XML files. Okay, so they are available inside the resources folder, inside the layout. So I have this main.axml file. Things have slightly changed in the recent version. Earlier you could have edited here directly in the main.xml, but because of the square and the round support, now you have two important XML files that you have to consider is the rectangle main and the rectangle round main. So you can go and add your code here. Okay, now without much of it, what I'm going to do is I'm going to run this, right, to show you how exactly. It's just a simple tab button, and if you look at the code, you all can see the code now? Yep. Okay, so I have an onCreate method where I am inflating. If you don't worry about it, this is all there in the documentation. All that you have to worry about is, see, that's a C#, and that you can do everything in Visual Studio as well. So you have a watch view stub that I'm getting an instance of and finding out a button inside that. And then I'm creating a notification. So because I told you watches is all about notification. So I'm creating a notification, and this is notifying the user right inside that app. That's all I'm doing. So you see that. That's my first thing. I am rect, tap me. So when I click on that, it says check notification. The way you check notification is you swipe from bottom. And when you swipe it, you see that button tapped 1 time. So this is a code that you wrote. Now you can swipe out the notification by swiping it on from left to right. So that's it. That's gone. So that's how users will be doing it. So to notify the user. Now this same piece of code is going to work on your Android app as well. In the sense, if you write notification compat and write this code, it will also make sure that it notifies your phone as well as your watch. Okay, right now what is happening is I am in the watch app and I'm just creating a notification. Okay? Yes, because as I told you, the Android app, the Android Wear app is nothing but an Android app itself, right? It's just that it's a smaller version of the original Android, which can run on your wearables. So it has the same feature. So if you know how to build apps on Android, you don't have to have anything extra to learn to build Android Wear. It's the same skills.
Yeah. So by the way, if you are new to Xamarin, if you want to learn how to program C#, using C# to program for Android and iOS, tomorrow there is a talk from my colleague Mayur. He has a talk on Go Mobile with Xamarin, C# and Visual Studio and Xamarin. So that talk will introduce you to how to program for iOS and Android. So this is morely, this talk is more focused on wearables because we have to cover a lot. So I'm not going to get into the details of those. So now if I have to create another button, on that screen, I will go to the, let's say, rectangle main, and I can actually drag and drop it, but I'll also show you the layout file, which is a simple XML file, right? So I can, let's say I want another button. I can copy for time being, or I can have a text view. Just make sure the ID is properly set. So I'll just call it as hello button. And I don't need any string from here. There you go. So I have a hello button. And since I am writing this in rectangle main, I also have to make sure that I have to write it on round main, because what is going to happen is there are two different files. So if your app is running on a rounded variable, it may not be visible. So make sure you write that. Build this app once so that all the resource identifier gets generated. So once it is done, you can go back to the main activity and just write pure C#. So let's say if I want to get a button, I'll say where, I named it as hello button. So I'll say hello button equals find view by ID. That's how you inflate a button from your XML and create a C# object. Resource.id dot whatever ID you gave there. So it's hello button. Now you got an instance of the button, right? So I can say hello button dot click. Can you see it's all C#? I can use async and await if I wish to, right? Obviously there's no awaitable code, so I'm just setting the text of it to say hello from C#, right? Let's run this and see if this all works. All I'm doing is taking a button, on the click of it, I'm just changing the title of it. Nothing, no rocket science. Let's see how it does this come up. So I have the second button. Obviously I didn't give any title, so I click on that. You see that? Pretty simple. That was just a hello world. Now let's get back to the slides. There's a lot more to that, right? You can do notification, you can do speech recognition. All that you need to do is go to the documentation, look at the API, and program it for that. Now, let's look at Apple Watch. Nobody has really seen the Apple Watch, so you don't know how exactly it's going to perform, but we have to believe that it is going to work because we are going to use the WatchKit, the same SDKs that Apple used to build its own apps on Watch. So WatchKit is the Apple's framework for programming Apple Watch. Now, what are the important key elements to this? One is there are three projects in the solution. You saw the solution, right? You saw one project, which is Android Wear. I should be having an Android application project as well if I were to package it and ship it to the real device. In Apple Watch, this is a mandate. You need to have three projects. One is your parent project, which is your regular iOS app. The second is the watch extension. Now the watch extension is absolutely no UI. It is something which you and the Apple OS knows that it exists. It doesn't have a physical form, okay? And then the third is the watch app, which is going to run on your watch. Now why did Apple do this? It's very simple. They just want to limit the number of resources that you can use on the watch. So you have a watch app which can only show the UI, and then any button click and all those things are basically handled back in your watch extension app. And that watch extension app can further connect to your iOS app. So remember, the WatchKit extension app is going to run on your phone, not on your watch. If you understand these three things, it becomes easier. Let's do a hello world on Apple Watch. Ready? So let's do it on the same solution, right? File, add, new project. And this time I'm going to go to iOS, go to the unified API, select the Apple Watch, and there you see the WatchKit app. Now before I do that, as I told you, I also need a parent app, right? So I go create a parent app first. So I go to iPhone and select a single view application. I will call this as hello, my first watch app iOS, and click OK. So this is going to create an iOS app for me. That's fine. Let that be there. And I can add new project, go to iOS, go to the unified API, select the Apple Watch, select the WatchKit app, and I'll just name it as WK at the end to differentiate between the two. So now I have the WatchKit app and the WatchKit extension, and I also have the WatchKit app iOS. Now the beauty about writing this in C# is that you can now have a portable class library and share the code between these two things as well. So the DLLs are going to can be referenced directly. Okay, so now a few important things to notice here. This may be a little confusing at the first, but this is how Apple expects you to do it. So here are the few things that you need to say. You need to first tell your watch app what is your WatchKit extension. So you go reference the WatchKit extension. So if you go to the projects, you can reference the WatchKit extension. Now that's done. Now your WatchKit extension should be known to the WatchKit app, right? So you go to the WatchKit app, sorry, it's the other way around. Go to references, edit references, and select the WatchKit app. Okay, so I have the WatchKit app, I have the WatchKit references, it's all referenced down. Now the thing doesn't end there. Now these are all good for development purpose, but when you deploy it, there are a few more things that you need to do. That is, your WatchKit app.iOS has a bundle signing. Do you know what's a bundle signing? So when you're building an iOS application, you have to make your application unique, right? You can create say an app called WhatsApp and ship it, but there should be a differentiator, right, between your app and the original WhatsApp. The way you differentiate is by using the bundle identifier, where usually it's given like com.yourcompany.yourapp. Now this thing is important. So I select this, click OK, and the same bundle identifier has to be existing in the WatchKit extension app and the WatchKit app. So I can go, now it's already done, so you can see that bundle identifier is com.nish.ios dot, and then there is WatchKit. Oh, I'm so sorry, nobody told me that you're not able to see it. You can see it now? So you have the bundle identifier, and you can also see there is another bundle identifier that I need to add to this plist is the bundle ID of the WatchKit app itself. So I'm just going to replace this. Now we're good. Once we do that, make sure you do the same thing even in the WatchKit app. So go to the info plist, remove this. Now if you fail at any step, absolutely there's no way to notify you any kind of error. So make sure you do that right. After that, go for a build. So we'll just run this and we'll see how this works. Set the WatchKit extension app as your start project, and make sure you select either iPhone 5 onwards because it doesn't work on the previous versions. It cannot connect to. Just run it. Just go to open an iOS simulator, and pretty much nothing is going to be visible here now, because if you go and look at the WatchKit app, it has an interface.storyboard, which is where you will design the UI. Now you saw in Android where you're designing everything in XML, right? Now for iOS, you will be designing this in the storyboard. So this is your storyboard. If you want a button, you can drag and drop a button here. There you go, right? What do you do if you are doing Windows Forms? You will put an identifier to it, right? So let's go and put an identifier to this. Properties. So I call this as my button. Now if I want to click on this button and set something, what do? Double click, yes. So once you double click it, you have this event handler. Now watch this. What has happened is your interface.storyboard exists in the WatchKit app, but your handler, event handler, does not exist there. It exists in the interface controller, inside the WatchKit extension. That's the key thing, right? So remember, your WatchKit app is only the UI at a front end, right? Now, on that click, I can just go my button dot. So set title. What is that? The set, yeah. No, this button is what I referenced in my interface storyboard. They are not extended, but you can share the code. Let's say hello from C#, it's a single string. You can have the class written inside a portable class library and then reference it if you wish to. You can do that. Okay, so I'm just setting this up, and let's run this and see. If something goes wrong, that means it has gone wrong in the bundle identifier, which we will fix it. There you go, it comes. There's a button. Do you see that? Now the way this comes is, you have to understand, if you're just running it, it may not come at the first time. You'll be thinking, what happened? Why is there no simulator there? Simple reason to that is, if you go to hardware, external displays, you can actually switch off that. So to enable that, you go to hardware, external displays, and enable the watch. There are two watch sizes. One is the 38mm and the 42mm. Right, so let's rerun this, because that's your button. Saw that? It's a simple C#. So deliberately, I did not go into the tough ones, because just wanted to keep it as hello world, because Wearable is completely new, and there is a different coding paradigm altogether. Right. So you saw the first watch app. Now, does that look good? Obviously not. It was a simple button, right? To make it look good, there are a few controls in the WatchKit. There's a label that you see on the screen. There's a button. You can also customize the button. Like, you can also add an image to the button. You have a switch, which is on and off. There's a slider. There is image, and there are little more controls, about 6 or 7 more of them that you can use, or you can also design your own UI as well. Now in WatchKit, just like how we saw this, notifications in Android, very similar to that, in WatchKit there is also something called as Glance. Glance is not a fully compatible app. It is just a simple screen that comes up and shows users something, and then when you click on that Glance, it actually opens up an app in your phone. So to give you a simple example, let's say if you're driving in map direction, you click on the map, and then that can open up the map in your phone. So that's something like a Glance. So it's a read-only, non-interactive view of app data. So you can't have button clicks and all those kind of things. It just can provide some information. It can only display data to the user. So that's what I meant. Tapping on the Glance view automatically runs the full watch. Okay. So I showed you controls. There's Glance, and one last thing is notifications. So as you saw on Android Wear, you can also notify users on Apple Watch. Again, even here, you don't have to do anything extra for the notifications. You just have to use the existing notification class in your iOS. When you run that notification, it automatically notifies on the phone. But there are some times when you can customize the notification. Okay, you can actually have buttons, action buttons on the notification. So if you want to respond to a notification, you can have it there. Or you want to do a speech recognition, you can do that. So that way you can customize the behavior and appearance. So what are the things we saw? We saw Android Wear, we saw Apple Watch, right? All in C#. Next thing is Google Glass, right? This is one of my colleagues. He has a Google Glass, and the way to look at Android, the Google Glass, is basically it's the Android for your face. You have to understand how does this glass work, right? It's a pretty cool make. It has a CPU right over there. Okay, it has a prism. It's a small prism. It is kept at a viewable angle. You can either mount it on an existing glass that you have, or you can wear it just like that, and it gives you
all the notification at a readable length. So what I've heard is it's as good as looking at a 42-inch TV from an 8 feet distance. So you get that kind of an experience out there. The few other things that it obviously has a battery, which is right behind your ears. It has a speaker, so it's going to give you some advices or suggestions, or it can respond to you. And it has a microphone, plus it also has a camera right at this at the beginning of the glass, or next to the prism. So what happens is you can shoot life as it happens in your life. So have you ever seen the photos taken with Google Glass? You can search for the hashtag called #ThroughGlass in Twitter, and you can find the people who have taken the photos. So it's like you're checking into a hotel. It has all the check-in, check-out details, plus you can take a photo of the hotel and upload it, so you have more information right to be shared across. Okay, to program for Google Glass, a few things that you need to remember is it runs on Android KitKat 4.4. Okay, that's absolutely it's very similar to the 4.4W, but that's wearable. But this is 4.4. It can connect via Wi-Fi or Bluetooth. So because obviously because of form factor, it can accommodate a Wi-Fi as well. And this is one good thing that Google did, is it connects even to your iOS device. So Android Wear never connected to the iOS device. It was only connecting to the Android phones, right? So now this would connect as well on iOS and Android as well. So the stores, the apps that you build on Google Glass are shipped into its own Google Glass store. As of now, every app out there is free. Any questions so far? Everybody's awake? Is wearable too much for this generation? Can the next generation handle it better? But do you believe that you can program for Wear? Yeah? Watch and Wear? Can you do it? Yes? Because it's your skill, nothing extra. Imagine if you're a C# developer, let's say you're an ASP.NET developer, and if you were asked to build a Windows Phone app, what would you do? What would you do? You would go into the Windows Phone documentation and figure out how to do things. The tooling doesn't change, the C# language doesn't change, the Visual Studio doesn't change, right? How you add references, how you edit references, how you write link, how you write lambdas, how you write anonymous delegates, nothing changes. All that you need to know is look at the documentation code. How many of you really look at the documentation code, or others would do a Google and code? Anybody who looks at the documentation and code? Great. That's the right way to do it. Don't Google, don't go to Stack Overflow, though you have to look at the documentation and then code. So to get started with Google Glass, it is available as a component. It is not available as a NuGet yet, but component store is very similar to NuGet. It was existing even before we had an integration to NuGet. So you can add a component. If you wish to add your own components, you can add it there. But Google Glass Development Kit is available there. So you just download that and write some code. So I'm not going to get into the details of code because it's too much of Android-ish code. And you can have a look at that. In this link, you have all the details there. Okay, last but not the least, does anybody know Microsoft Band? Do you have one? You should catch those Microsoft guys. They are around here, right? Now, the good thing about Microsoft Band is it is going to work with all of the phones. They didn't say, okay, we have Windows and it's going to work only on Windows. The band can connect to your iOS and Android devices too. So it's a multi-platform support, works on Windows Phone 8.1 and above, iOS 7 or later, and Android 4.2, that's API 17. So Microsoft released SDKs for this. It's simply because when you want to develop for wearables, you have to consider all the market share out there, right? So you will build for Android Wear, you will build for, obviously for Apple Watch, and you'll also have to consider this market share because the health fitness freaks are going to use this because this gives a lot more information than the other ones as of now. So to get started, again, it is available as a component. So you can download a component from component store and start with few lines of code. Don't worry about what's written there. It's simple. There's a band client manager, and you initialize the band and then create a context and pair the device. So you need to pair. So how that works is through the Bluetooth, and it works very seamlessly. You don't have to worry about connecting to the Bluetooth and finding out whether there were errors in the data packets and all those things. It's all seamless. Any questions? Yes, they are all free. Everything is free. This is not from Xamarin. The Microsoft Band component is submitted by Microsoft itself. Google Glass is something which we created. Android Wear is also what we created bindings. That's how we bring the existing Java SDKs to C#. So this is a code to access sensors. So you have there are a number of sensors in Microsoft Band, so you can have a look at the documentation. So there's a gyroscope, there's accelerometer, and with all these data, you can create a really nice app for the band user. Yeah, and also there is tiles. What's a tile? How many of you are awake? How many of you know that you're still in the wearable session? Right. I know it's hard after lunch, but this is your future. Think about it. So go back home, give it a try. It's pretty simple. You just have to install Xamarin and then get started. So updating tiles is very simple. So Microsoft Band has tiles just like Windows Phone. It can give you notification within the tiles. So you can also configure this for the tiles. So that's it, right? Time is now, go build the future. Are you all here to build the future, or are you all here to build what manager says? Obviously, what does it take for me, right? Build the future, because you have the capability and ability to build into the next. You have, obviously there are IoTs, which is coming up, all based on sensors connecting to the cloud. These are all the next form, where wearables is also emerging as one of the major technology in this decade that we're going to see. Few things that you can read. Everything is available on developer.xamarin.com. There is a forums where a lot of people like you who are interested to build on wearables are actually chatting, and have some interesting code there that you can actually copy paste if you wish to. And there's a lot of information on our blog, and all that I showed you, this is just a Hello World app, but there are some really interesting apps which are there in GitHub. github.com/Xamarin. Search for Android Wear, search for Google Glass, or search for Apple Watch. That's the WatchKit, and you have everything there. Last, don't limit yourself to the documentation of the Xamarin, because you're a C# developer, you can go to Google documentation or Apple documentation and technically write the same code that you see in Objective-C, or that you see in Swift, or you see in Java. You can write the same code in C#, because APIs don't change. It's only the way you write it in C# changes, right? So make sure you read that. Also, don't forget to visit our booth, where we can show you how to build your iOS and Android apps if you still believe that smartphones still exist, right? You want to build for your smartphone. How many of you have an Android device here? Okay, iOS device. Windows Phone? Fair enough. So that's the market. That's how the market is. You have to build for everything. So we'll show you Android Wear and Watch demos. If you would have come to a booth, you would have seen Google Cardboard. Have you seen it? Did anybody see the Google Cardboard? So it's the virtual reality from Google. I have a cardboard box with me. You can see how to program the Google Cardboard, and that's very interesting. You can also see beacon demos. What's a beacon?
Bluetooth 4.2 device which can translate. You can basically use it for indoor traffic.
Correct. It can. So it's a BLE. It's a Bluetooth Low Energy device that can be kept in the indoor. So let me give you an example and explain you. So think about a situation where you parked your car in a mall, and you actually forgot where you parked.
Have you faced this situation in your life? Can GPS solve this problem? Let's say if you're checking in at the place where you are parked the car, can GPS navigate you? Obviously not. You may be in the basement of this one, right, where GPS is not acceptable. So you can have this low energy beacon devices and have the geofencing code to figure out where exactly this person is, and then navigate him to the possible place where he has checked in. So you can do all those kind of things. Or other things, you're walking into a shopping mall and there is a Nike or Puma store which automatically says, hey, we have a discount of 50%. How does that happen? Because as you walk in, the Bluetooth low energy devices, it doesn't have to be paired. No pairing is required. It can send information. So if you want to see that beacons in action, come to a booth. Also, you can win the C# t-shirt. It's a very simple app that you need to download and execute to win this t-shirt. And this t-shirt comes to your home. So it's not something which is there with us here. It comes from San Francisco directly to your home. We want to ensure that it's only C# developers who are trying this whole thing out. Okay, so we have kept a small bug in that app. So when you execute it, it's going to tell you, here's the bug that you need to fix. It exactly will tell you the line which you need to fix. So you just go to that line and fix that bug and win this t-shirt. Also, you can take away these Xamarin plush monkeys, which if you ask me the right questions now. With that, that's about it. Thanks for joining this session on wearables and go build the future. Any questions?
What is the difference between Xamarin and
Fairly, Visual Studio doesn't run on Mac. So I was showing all the demos in Mac, so I was using Xamarin Studio. So Xamarin Studio is a free IDE that runs on Mac. So you can run whatever demos I showed you right now, it's going to work on Windows and Visual Studio. But remember, if you are working for Apple Watch or iOS, it needs to have a Mac because that's a legal restriction from Apple. Any other questions? You can take the monkey. Huh? The latest stable edition. Yes. So the thing is, you can update Xamarin Studio. It's a free edition, right? Every update you can update it. So I think it is 5. I don't remember the exact version number. But more than the Studio, you have to give importance to the Xamarin Android version. Right? Xamarin Android is a subscription version that will be used to build. So not the Xamarin Studio. It doesn't matter. Xamarin Studio is a simple IDE, right? So I don't remember this one, but I can check that and we can connect offline and tell you which one exactly. Yeah.
what's the target .NET framework?
So, okay, here's the thing. It is not running on .NET Framework. It is running on Mono. Anybody knows Mono? Yes. So it's the Mono, and it is it has features of all the .NET Framework 4.0. Not all, but whatever is required for the mobile development.
Like when RT was there for Windows 8.
Yeah. What is the API set you're talking?
API reference, like when RT was introduced as a part of Windows 8 OS.
Mm-hmm, mm-hmm.
Do we have a new set of APIs for this?
It's not a new set of APIs. It is, how do I put this? So you are asking, does Xamarin has this?
See what API does. It connects to the low-level programming Windows and try to upgrade the Windows, create a Windows. So Microsoft came up with a new set of APIs to track with the low-level hardware design.
Are you talking about Microsoft Band in general?
Given the application what you're going to make, it has to connect to the Android OS and create a Windows out of it.
So no, it's not like that. That's a wrong understanding. So how we do this is, there is something called android.jar. That is where the entire Android sits in. And every version Android releases, there's, let's say 5.1 or 4.4, 4.5, whatever it releases, it has a jar. So we write bindings for jar. So have you heard of JNI? Java Native Method Invocation, where from C# you make a Java call? That's what we are doing here. Yeah.
Do you have the same thing for the wearable concept?
It's a very small device. Do you really need that? So Xamarin Forms is basically abstraction layer to control your UI, but we don't have any plans as of now, but I don't know. It may be there in future. Yes. So business logic can be shared on PCL. I mean, everything, like let's say message that you want to send out a notification can be shared, but the way you build the notification on every platform is different.
So this ID itself contains the code.
Yeah, it's not the ID exactly. There's something called a Xamarin Android subscription. That has the DLLs that will do the rest of the job for you. So ID is just giving you that C# and all those other kind of things.
Creating as a form or project, web project, how we are creating Secret Studio, how we are creating the project for this Xamarin this application.
Yes, so when you install Xamarin, if it detects a Visual Studio on your system, it will add templates for it. Okay? If you want to see the demo on Windows, you can come to the booth. I'll show you that. Any other question? I will give you this. Sorry. Any other question? Yes. Yeah, it's a single packaging.
So if we want to mount the app directly to a variable which can connect to the Android app through internet without having to install the parent app.
So no, you can't do that. So there is a restriction that way. The way you package it, if you want to really package it, and see the way I'm doing it, you can actually deploy to your watch, but that's not the way it comes from the store. So in store, you will package these both of the things, right? And then it will be submitted to the store. So you need that packaging together, just like how you saw bundle identifier in Apple Watch. It's a similar logic where you will update the XML file, manifest file, to say what is your wearable app that you're shipping along with this.
The bundle we are creating is for the Android mobile phone.
Yes, but when you package it, you can also package the Wear app as well together. Okay, thank you very much.